In this lesson, we're going to develop some symmetry properties by considering complementary angles. Now, we're going to start by having a look at this triangle here. It's a right angle triangle, standard right angle triangle. There's an angle theta. We have the sides labeled A, B, and C. And we know that, for example, the sine of theta would be A over C, opposite over hypotenuse. And the cosine of theta would be adjacent over hypotenuse, which is B over C. Now let's consider this angle here. Now, if all three angles in a triangle add up to pi, 180 degrees, then if this angle here is pi on 2, and this angle here is theta, then what's left over for this angle here? It's got to be pi on 2 minus theta. Now, let's consider, I'll just do it verbally, then I'll write it down. Let's consider what the sine and cosine of this angle is. Well, the sine of pi on 2 minus theta would be b, which is opposite this angle here, over c, opposite over hypotenuse, b over c. But b over c is also the cosine of theta. And so we have a relationship for complementary angles, angles that add up to 90 degrees, that cos of theta is equal to the sine of pi on 2 minus theta. And similarly, for the cosine of pi on 2 minus theta, we have adjacent over hypotenuse, A over C, which is also the value of sine theta. So sine theta is equal to the cosine of pi on 2 minus theta. I'll write those down. Normally we do it this way around. So we say that the sine of pi on 2 minus theta is equal to the cosine of theta, and we have the cosine of pi on 2 minus theta is equal to the sine of theta. And that is our complementary angle relationship. So I've got here, as you can see, the general rule when coming from the y-axis. I'm going to come back to that. We can basically swap sine and cosine. And you'll see that in action for a second, in a moment, sorry. Let's have a look at this. So via the unit circle, in quadrant 1, if we're asked to find the sine of pi on 2 minus theta, then we are looking at this spot here as being pi on 2 minus theta. And therefore, by definition, that has to be theta here. Okay? So if we're trying to find the sine of pi on 2 minus theta, we simply work out what the sine of theta is. The cosine of theta is, and we say they are equivalent. Okay, we use these two rules here. Okay, we'll see that through an example in a second. Let's have a look at the second quadrant. Okay, for the remainder of the quadrant, we first consider theta to be acute, and then we will at the end extend to non-acute. So we're assuming that theta is between 0 and pi on 2. So in quadrant 2, pi on 2 plus theta would look like this, with theta in here. Now we're going to always start off with swapping sine and cosine. And so sine of pi on 2 plus theta is equal to, bear with me, cosine of theta. I've left a gap there for a reason. And the cosine of pi on 2, plus theta is equal to sine of theta. But you can see that in quadrant 2, we are going to be, using our cast diagram, we're going to be having positive sine values and negative cosine values. And so we're going to have to go cosine of theta, that's fine. And the sine of theta is going to have to be negative sine theta. In other words, sine of theta will give me some sort of positive number, and then we have to make it negative in order to make the cosine negative, because all cosine values are negative in this quadrant. We're going to follow the same sort of logic for each of the quadrants here. So 3 pi on 2 minus theta is going to be from here down to here. So I'll just put my angle theta in here. And so we can see that in the third quadrant, we are going to have tan as positive and sine and cosine as negative. So sine of 3 pi on 2 minus theta is equal to negative cosine theta. So I've swapped over to cosine, and I'm going to swap over to sine, but I'm going to make it negative because the cosine of an angle in the third quadrant is always going to be negative. Fourth quadrant, we've got 3 pi on 2 plus theta. So we've got 3 pi on 2 to that point, and then plus a theta gets us into here, into the fourth quadrant. And then we are going to do the same sort of swapsies again. So sine of 3 pi on 2 plus theta becomes cos theta, and then we need to think about the sine, SIGN, and then cosine of 3 pi on 2 plus theta is going to become the sine of theta. We need to work out whether it's positive or negative. In this quadrant, we have cosine as positive, so this will just be sine theta, and in this quadrant, sine is negative, and so we will end up with negative. So it's basically saying work out what cos theta is, we'll get a value, and then make it negative, and then we're good to go because sine is negative in the fourth quadrant. Now, what about tan theta? Tan theta we haven't looked at, but if we needed to work out what tan theta is, we could do it fairly easily. So if I was working out, say, for example, the tan of pi on 2 plus theta, I would use my identity, which says tan equals sine on cos, to go sine of pi on 2 plus theta over cos of pi on 2 plus theta, and that will equal cos of theta on top, because sine is positive in the second quadrant, over negative sine theta, because sine is negative, because cosine is negative in the second quadrant, and that would be something that we could work out. So negative cosine of theta over sine of theta. You can see that effectively we get the reciprocal of what tan theta would be. Okay, so tan theta is sine on cos, cosine, so tan of pi on 2 plus theta would be cos on sine, and then made negative because it's in that second quadrant. So it all works out. What about if theta is not acute? So every single time we've assumed that theta is acute. So when we say pi on 2 plus theta, we're just adding a little bit like that. Well, it turns out that if theta is not acute, these relationships still work. So we don't really have to consider whether theta is acute or not when making this straight swap like so. There are further considerations that do need to be made, though, by considering what quadrant theta is, but it's best if we illustrate that through example. So I'll stop the video here, and I'll do a second video with examples.